Do not attempt to adjust your screen. You don't need to flip your phone. It's just the amplifier's right side up, wrong side down. So this is a Mirage 150 watt 2 transistor solid state amplifier. It's good for 50 through 52 megahertz. I got a beautiful handwritten note, and it's like when I called and I talked to the customer today. His phone number, he had one digit that didn't make any sense to me. It could have been a 0, or the top portion of a 0, or a 7, or a 6, or a 2, or even a 5. I'll get back. My teacher, my mentor, and my friend, Mr. Minister, is calling me. Okay, let's see. Let me get my thoughts back. Mirage. So this amp should not do more than 150 watts. Now, I'm looking at this particular transistor that's in this thing, which this has got 2 SRF 3605 transistors. One here and one here. Let's come over here and let's take a minute and let's look at the layout on the internal workings of this beautiful 6-meter Magic Band amplifier. What? There's no transformers? That's right. It's all induction driven. And it's all traces on this particular thing. Kind of cool. This is your input circuit here, believe it or not. And this is your output circuit right here, believe it or not. All done with inductors. So there's lots of little details, like how they're doing isolation chokes with the windings on just even like little disc capacitors. I don't know where you're deciding to focus, camera, but you're not focusing on the top end of the show here. Maybe I should spend some money and buy that other lens. Should probably do that tonight. Nope. Nope, nope. Not taking that call right this minute. So we have our standard power incoming system over here. Comes in from the outside world, comes down, goes through a little fuse, comes across, gets dumped directly onto our input circuit. Boom. We got our transformers and we got isolation chokes. RF comes in, RF goes out. Got our preload induction coil, our output network combiner / transformer system, which is all done with inductors. Tuning coil, bypass cap, or a blocking cap, and out through a little inductor, through some coax, back down through the primary relay, back out through the relay, over here to this connector. Pardon me, out through the relay, through a bandpass filter network, and then out. Very simple. Now here's the problem. He said the power level fell off, at least on his meter. And he's saying that his friends are watching him on their fancy radios, like what he's got, what I have on my workbench, and it is showing signs of saturation. Okay, cool. He also has pointed out that the preamp is in op. I don't know, I've got to pull the part number off of this transistor. Over here is the keying transistor. This here is also a keying transistor, but it is for the external PTT button. It is an auto key, or it can be a manual from here. But your whole preamp circuit is a tuned circuit that's right here. This little section is our preamp circuit. And I've got to pull the part number off that transistor and figure out if I've even got a cross that'll fit in there. This is an NPN, just like a 22 2N2222. I noticed that you noted and you took note in your very thorough documentation that you replaced your actual auto key circuit with your 2N2222. This is your bias circuit, by the way. We don't want to touch that. We're going to leave that completely alone. No, we don't want to put a screwdriver in that because it'll make it do more power, but for a very short amount of time, and then it's going to go pop, Bob's your uncle. Now, if you have seen output fall off, it's going to be because either one of these two capacitors or this capacitor have gone bad. Either that, or somehow these caps have jiggled loose. I don't see any signs of the jiggling loose, and I don't see any signs of anything being out of balance. So let's go ahead and let's take a look at what it does in operation. So let's start off over here. Things are a little bit different from normal. We have a 25 through 60 megahertz 100 watt element. We have a 25 through 60 100 watt element, bird element, and a 5 watt 25 through 60 element and reflag. We're going to use the ICOM. Where are you? Where'd we go? Oh, we're not there yet. Where are we? Oh, here we are. We're going to use the ICOM 7300, and let's go ahead and do it like this. Start out in AM, and let's get our power level brought up. So let's go over and take a look at these 2 meters. Let me zoom out a little bit. Now our amplifier is off at the current moment. Now this is an incredibly low drive amp. So what do we got? About 1.5 watts worth of input. Half a watt worth of carrier. Producing roughly 20 watts of power. There's 100 plus watts worth of carrier. And we're not even at 50% on the ICOM. We'll go ahead and flip our multiplier up to the 2x position. Back this up just a little bit more. Multipliers in the 2x position. There's 150, 180, 200 watts. So now that we've max saturated the circuit, let's grab our FLIR and see if we have anything breaking down from temperature inside the amp. Our load resistor for a part of our bias circuit's getting hot. Our resistor for our on indication light is getting hot. The 2 transistors aren't even warm. That's interesting. None of our capacitors are hot. Okay, so let's go ahead and we'll shut the amp off. Hello. Let's put this thing on sideband so we can actually get it to get some forward movement going on here. Let's run this up a little bit. Hello, audio. Hello, audio, 1, 2. Back down to 1x. Hello, audio. 1, 2, 1, 2. So we're making about 40 watts worth of power, which is way more than what this amp needs to get it up to where it needs to be. Hello. Say 20 watts worth of input signal. Hello. Oh boy. Go up to 2x. Hello. 200 watts plus with 20 watts of input power. Hello. It's looking pretty good to me, mister. I don't know about you. Let's get this turned on. Let's get this turned on. Start making some measurements. Let's see, does this radio over here go to 6 meters? I think it does. We'll type in 50. There we go. And our band selector. Go to AM. So I'm going to have the spectrum analyzer, and then I'm going to actually hook up over here. Now let's see, are we playing on upper sideband? Hello, 1 2 1 2 1 2 1 2. Okay. Hello, 1 2 1 2. Wow, exactly 5 kcs wide over there. Let's see, what are we seeing over here on the spectrum analyzer? Hello, 1 2 1 2 1 2 1 2. Hello, 1 2. I am not seeing anything showing me that I'm oversaturated on either the spectrum analyzer or 25 kcs wide. Lovin's, I know. Fun package. Let's see if we can use all of that. Wife had to pop out. She's seen our package from Amazon showed up here today. Spectrum analyzer is not showing me any issues. Hello, 1 2 1 2 1 2. Okay. Hello, 1 2 1 2 1 2. Hello, 1 2. Not seeing anything jump out at me on the scope either. Now let's come on over and let's listen to it for real off the air. Okay, as we clearly can see, I don't even want to bother with any of the filters. We're only 25 kcs wide, and let's see if we can drive this thing to deviation here real quick. Hello, 1 2. Hello, 1 2. Sure enough, there it was. So what are we putting into this thing for power? Hello, 1 2. Not much. Hello. Yeah, no more than 25 watts carrier, period, or input power, period. When we start seeing all these little side ripples pop off, that's from us getting oversaturated over here. All right, so now we're back over here on the workbench again. Hello, 1 2 1 2. It's about 20 some watts worth of power. Let me show you what I mean. Let me flip that up to 1x. Hello, 1 2 1 2. 20 watts. I wouldn't put any more than about 20 watts worth of power in this amp. But the point is, we're running it through its paces. We're down on a 5x. Look at all the time we've spent transmitting with it. Hello, 1 2 1 2. This thing's making 250 watts of power with 20 watts of input power. That's a lot. These two little transistors. Hello, 1 2 1 2. It's a beautiful thing. Let's go on up here. Let's see. Let's look at this here. This is our input. It's a 2 through 30 megahertz, or 25 through 60 megahertz slug as well. Hello, 1 2 1 2 1 2 1 2. I am not seeing a problem with this Mirage. I'm just not. So let's grab our FLIR one more time. Let's take a look on the inside and see if we see any overheating issues. Once again, this little tiny resistor for our LED is the hottest thing in the front of the box. Our bias resistor here in the back at 71 degrees. But our actual transistors, friggin' ice cold, man. None of our other capacitors, nothing in here is hot. So short of giving you real power wire leads that come on the inside of this thing, that's one thing I haven't bothered to look at, is how many amperes this thing is pulling. So let's see what the non-scientifically based general amp meter says here. Hello, 36 amps. Spot on the money. So the only problem with this thing right now is the preamp. It will be hell. Will freeze over before I go in here and I start screwing with any of the adjustments inside this box. It have to be something seriously seriously wrong for me to come and play with any of these trimmers whatsoever. As you can tell, I'm not in a hurry to stick my fingers in here. Why? Because everything's working better than it should. Amp is only designed to make 150 watts, and it's making 200 and 300, almost 300 watts with 20 watts of drive. It's pretty safe to say that this thing is working just fine. We've triple, quadruple checked it on the spectrum, looked at our signal through our oscilloscope, and then looked at it on an actual full-blown HF receiver. I feel fairly confident to say that with a lot of certainty this thing is working well. I did read in your note where you're interested in putting a little fan on this thing. Okay, if we could get it to come up over room temperature. Well, the last couple pieces of video that you guys just got done watching were shot Saturday of last week, and I thought I'd take on trying to repair this preamp. I was really impressed with the circuit itself, and it didn't make any real sense to me when I first looked at it. I'm like, this is not set up like a transistor, this is set up more like a MOSFET. So I went ahead and removed the old transistor, which is in this bag. Come to find out it's a JFET. It's like a 1301 JFET, at least according to the schematic. This part's been obsolete now for a long time, not manufactured. So I was like, well shoot, what am I gonna do? I went and I got in one of my books that apparently has got a cross for it. It's like a 1303T is what the 1301A cross is for it. I ordered one of those JFETs. Now, let's go down in here and look. So I got my tester out and I pulled this. Focus, you son of a gun. Focus. Focus. There we go. When I pulled this transistor out, it is wide open. Okay, it reads as a diode, so it's shorted. So I put our new JFET op amp in this thing, and we're going to quickly align it. This is an actual preamp. Like, it's not some shitty little transistor that somebody pulled out of a drawer. This is a literally designed preamp that is tunable. So it's only going to hear a certain spectrum instead of rectifying everything all the way across the whole spectrum. It's only going to rectify just what we want it to. So how we test that, I mean, most of the time, the transistors have a noise floor that's such that when we turn the preamp mode on, you're going to hear all this static. This huge increase in static because the preamps are so poorly designed with the noise threshold so high in the transistor that all you got to do is listen to hear if the static level increases. This ain't that. So I was like, well, I got to get out my signal generator. So first I got out my my IFR. Was it the 1500 or whatever I've got? And I didn't, it's got a dirty pot in it, so I got to take that back apart and figure that out later. So instead I grabbed my KC901 network analyzer. The venerable goes everywhere, does everything, portable oscilloscope including a freaking fleshlight network analyzer, and it's got a TDF function in it and a signal generator and all that kind of stuff. So I dialed up the same frequency that we've got on the front of the radio, which is 50.1.4. Now, what we got to do is tune this JFET's frequency width to match our incoming signal threshold. So let's fire up our generator. And let's see, if I'm reading that meter right, and you're reading it with me, I've got the generator turned down to such a point to where it's hitting us just below 4 S units. So let's come down here, first turn on the amp, first engage the preamp. So we've already made progress because it didn't kill all the signal. See, look, I can literally tune all the input signal completely out of this. Beautiful. That. Okay. That's that. The noise floor on this transistor is outstanding, and the circuit is quiet. Freaking dig it. So, make a long story short, our preamp is fully repaired in this thing now. Now I went ahead and I did some power wire upgrades. I changed out the old strain reliefs and went with real 8 gauge size wire, so I would strongly suggest that you run this to whatever you need to run it to. That's about the size of wire that you need to hook up to it. This thing works just the way it did when it left the factory, and I think this is the first one ever where I'm not in changing out capacitors or I'm not readjusting something and being like, oh look, it makes magically more power. I'm not going there. He wanted me to test it, he wanted me to verify that it worked and was working correctly, and then he wanted me to do any modifications to it that I felt was necessary. The signal that this amplifier is generating is well within any kind of concern of frequency occupation, side harmonics, any of that stuff. None of that's happening here. It's got all the right traps in all the right places. You know, like that song from One Republic, all the right moves in all the wrong places. It's got all the right traps in all the right places. And I feel very confident in releasing this back to this guy and saying, here, it's all repaired, including the preamp. Which when it came in here, if you turned the preamp on, it would suck your signal to 0. So we were able to find a JFET replacement component, and it's been installed, and both of our trimmer caps have been properly aligned to prevent oversaturation of the JFET and causing it to pop again, but allowing you to add a full 2 dBs worth of signal gain to it. So anything more outside of that, we've seen what happens. A transistor gets oversaturated and it just drops off. So we're going to leave this be. This is where it's going to sit, and I'm going to call this thing completed. Cute little 6-meter amplifier. Very, very cool. And I'm grateful that you were willing to send this precious gem up to me. I know you've owned it since it was brand new, way back when. And I'm grateful that you sent it here, and you were willing to let me take a look at it and get inside and play with it. Very basic circuitry, very easy to understand, just very straightforward. I'm going to put the tin on it. I'm going to seal it back up in its stock bag that it came in. I'm going to just seal it back in the stock box, and I'm going to get it boxed up again, and I'm going to send it on off to you, man. Mr. R, please enjoy. It's going to go on and work for you for many, many, many more years. The other thing I did is I went ahead and I took the antenna relay apart, and I went through with the appropriate cleaning tool, which is a varnishing tool, and cleaned the contacts on this so it's just like it was when it's new. I don't think you're going to have any problems. Do we need to add a fan to this? No, just keep your QSOs under an hour and you'll be fine. It's a lot of heat sink for 2 transistors, and they're spread way apart. One over here, one over here. Lots of room. And if it gets too hot, your thermocouple that's sitting in between the two will just shut the amp down. So I wouldn't worry too much about adding a fan. Gentlemen, my name is BBI. Without a shadow of a doubt, I am the biggest mud duck sitting out here in Idaho. Whatever that's good for. Come follow us on Facebook and BBI Amps, the group. Come follow me on Twitter, Snapchat, Instagram, and right here on the YouTube Gargler. If this is the first time you've tuned in and like what you've watched, please consider just subscribing. That number helps a lot in the algorithm. Helps keep me at the top of the list for when people do searches for stuff like this. It allows us to be able to pass the data that I'm able to teach people here on quicker. And those are all good things, I feel. Gentlemen, I'll see ya. And thank you, every single one of you guys, for your continued support. Bye.